All right, hello, welcome back. We are back with some kottefolket here, game dev log. So, it's been some time. It's been like a week maybe, or something like that. I don't remember really, but I'm trying to remember what we were doing. We were upgrading like the collision system stuff or optimizing it, but I don't remember if we moved on from that or if we yeah, so what we did was collision system. We also made the Z-Tracy stuff work so we could profile what is going on, and we tried a bunch of different optimizations. Oh yeah, now I remember. Right, so we ended up with choosing to, since this game is mainly like a tile-based game. Well, this might work for many different types of games, but and not, you know, purely tile-based games, but really if you like divide the world in the spatial grid hash thing, grid spatial hash, I don't really know what the term is, but some kind of more efficient, more easily calculated grid-based or lattice-based or whatever you want to call it. Like essentially, you have a grid that you say that each cell has some information. They could be, so in my game, each cell is either solid or not solid, which is very simple and basic. And so essentially, it's just a tile-based. It's just a grid of squares that are either solid or not solid. And so, if the player is like within some of those squares, then we know that we have a collision. So basically, that's the system that we want to expand on. Because what I was trying to do before was to just use a quad tree to handle everything. But what I'm thinking of doing now is instead I'm gonna try to have two systems. So I have one, which is the grid hash based system, which is only for, you know, the tile maps. So only for like ground tiles, you know, solid tiles, and then for like ground collision, and then we're gonna have one collision system for the dynamic stuff, which is the quad tree. So that is what I'm going to do now. Let's see. So then like queries in, which will result in queries into the dynamic quad tree will be much faster. And they were pretty fast before. They were very fast before, like single queries. However, like the resolving of collisions past, that was actually very slow. And that is why when spawning a bunch of gems actually slowed down my computer. And so what we're gonna do is we're gonna try to move over to this new system. So I remember that so let's get started here. So I remember that we actually started an implementation of this. So we have this grid hash struct here with just an array list of data. So we don't have a 2D array, we just have one array. And then we have some descriptions here. We have the grid size, which is like the number of cells in each dimension. And then we have a cell size, which is how large is each cell. And then we have an offset, which was because of if you want to translate a position, like the player position, for example, which is 0, 0 is like in the center of the tile map. So we have to, like, if we want to translate that to a grid based thing that we have now, we have to kind of move over, translate the player coordinates up into the top left corner first, and then or each point will be translated by that same amount, and so then we can convert the coordinate systems to be able to use them. So because the grids based system uses, you know, it's a lattice system, so it uses integers, while the player coordinates, like the quad tree, uses floating point numbers, and 0, 0 is like in the center of the world, and the tile map's actually based around that as well. It's the center of the tile map's actually also in 0, 0. So that's just how it is right now. I'm not sure if I'm gonna change that to better match what we have here, so we don't actually have to do that conversion, although it's not really a huge deal. So I'm not gonna do anything with that right now, but if I had this design in mind from the start, then maybe we could do something like that. I'm not sure if it might mess other things up. But anyway, so we have this grid, and we also have, you know, this get intersections function, which in theory should return all the intersections of solid tiles that we have. And so this should already all be implemented here. And then we also have this stub if because this is like a generic game engine, so it's like, yeah, if we choose to not use the grid system, then you get this stub, and basically it's not there. So anyway, it's just to make it fit with Zig's stuff here. So let's see. So we have this grid thing, and then where's this used? This is used in the collision container, which is kind of the main collision system, which has everything needed to know about collisions except for like the actual bodies that is stored somewhere else in the physics system. But this is the collision container, which has the the kind of quad tree cache. It has the, well, now it has the grid hash here as well. You can see if grid hash is enabled, and we're using the actual grid hash. If it's not enabled, we're using a stub, which has 0, you know, bytes in size. So that's actually kind of nice that you can. I'm not sure if this pattern is like super good, but you can, in Zig, you can say like, okay, well, this is conntime value, so we can decide the type of hash. If we decide to use it, then this is gonna take up space. If we don't need it, then it's gonna take up 0 bytes. So it's essentially like it's not there, which is kind of nice. Okay, and then we can use it if we have it, or we can not use it, you know. You can even have comp time checks to see, like, if you're trying to use a grid hash function on the collision container while this is not enabled, then we can even have comp time warnings or errors, I mean, that says that, hey, you need to enable the grid hash before we can actually before you can actually use it, which is really cool. Okay, so now, are we actually using this anywhere? That's what I don't remember how much we did here. So, okay, so that seems to be the extension of what we did. So we have it in initialize, we have it in deinitialize, and then we also have this new set grid hash function. And what I said here as well is like if, actually, yeah, so we can say here, like if what you can do is actually just call a function here. We can call a function that is like check grid hash availability or something like that. And it's just a void. And what this is gonna do is just, we're just gonna check if config is grid hash enabled. If it's not enabled, we're gonna say a compile time error, and we're gonna say you need to enable grid hash to use this feature. Okay, and then we simply call this function, and during compile time, if this was false, then this would return an error, or this would like report an error. So if we simply put this in every function that uses the grid hash, then we have sort of a, you know, a comp time, so you don't get like runtime issues later. Or, well, you wouldn't get like, if we use the stub, you would basically not be able to use the grid hash anyway, but it's better to have this like this anyway. But I'm not sure about this pattern overall, but there might be like a better use, like a modular system instead, that you could like potentially have multiple different like collision systems working together in another way. But yeah, in a more generic way. But anyway, now I'm just trying to get this working for the first time here. So yeah, so the idea is that you set the grid hash. This is going to be set. So essentially it depends on how dynamic your map is. But my map is basically just static. It's a static map. So we essentially just need to call this once, and it's gonna populate the grid hash. It's gonna be called every time we kind of change the map, I guess. Like every time we want to change. If you transition to another scene and we have a new map loading in, then of course that's gonna be populated there as well. So it's gonna be populated. The grid hash is then populated, and then we can actually use it to find collisions on the grid hash. Okay, so and you need to provide these functions, things here. So we have like a context which you can pass into this isTileSolid function, which we provide here, which just says that, okay, well, given this coordinate and this context, is the tile actually solid or not? And we can provide a what is the grid size, what is the cell size that we already went through, and the offset. So that will basically just, yeah, it basically prepare the grid hash for us to be able to use it later for checking tile-based collisions, like ground collisions. Okay, so we've got that. Now, I don't remember if we actually implemented ground intersection checks here. I don't think so. I don't remember. No. Okay, so let's see. Also, is this used here? No, so this is not used in this because we don't have an example. The executable in this project, the game engine project, only uses like the quad tree, and yeah, there's no like grid hash. There's no grid hash test. I mean, I guess we could just make like a really, really simple grid that we can use. so that we can test this here. Before we actually test the game thing, because the game is like more advanced, so I would like to test the more simple thing, work out the issues that we get and all that before. So let us go to the debug scene here, and we need to create some kind of grid thing. So I'm just gonna say like we have like a tile map, or yeah, sure, whatever. Just like a very simple tile map. Let's first make a tile map struct. All right, so now let's see, let's have like data. Essentially, it's just gonna be like a bool slice constant, and we'll have the grid size, which could probably be the same thing here. Grid vector generic usize. Okay. And then we also have cell size, which is a vector, I believe. Yeah. And then offset, we'll deal with offset later. So that's our tile map. Now let's just make a tile map here. All right, so let's make it like, I don't know. So how large would this be? I don't know. Let's just make it like 8 by 8. Cell size, I'm not sure actually what the cell size would be. That would depend. Okay, let's just start with something here. Let's just do like 32. All right, so here we'll have, you know, it's a bool, so essentially it's like a, you know, you'll have like true, 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 true. So that's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's our tile map here. Everything is true. Yeah, I forgot we have to have dots over here. There we go. And oh, I went back to like JSON format for some reason. That always seems to happen once, you know, you've been away a little bit and you come back and you have to sort of get back into it. Okay, so data, right? So let's have, I don't know, maybe we'll do something like this, and so this kind of like a border here, and then we'll have some stuff in the middle here. Maybe even like something like this, corner. Okay, there we go. Oh, nice. It actually formats this kind of thing here. That's really cool. Okay, so we've got this now. So that's our time map, and then we'll add this over here. So we'll add. Well, actually, we already have the time map. We don't need to. I think that functions can actually refer to this, right? It's like a global, yeah. So we don't even need like a context or a closure here. Okay. but we do need. No, the physics system does work. Now, the new thing about that I did here is that now you have to use like a ZGE config in your in the game engine. Excuse me. And here we can provide some specific things. So, for example, enable grid hash. We'll set that to true, which will then, everything else is default. So this is specifically saying that we want to now use the grid hash. Now we can also check to see if the compile error actually works. But for now, oops, excuse me, grid hash is missing structure grid size. Okay, let's use 0 for now. All right. So anyway, we have the time map, we have the physics system, which includes the collision stuff. And let's just run this to see if this still works here. And there we go. We have our little physics simulation here. Now what I'm gonna do is I'm gonna disable all of this stuff for now. Where's the thing? Here we go. This one we will disable. Oh, it's already disabled. But where is the thing that we do? Where we add all the things. Okay. So let us. Let's do this. Let's disable that. And I guess we could keep all of this, except I want to lower the amount a little bit. There we go. If we run it now, we're gonna see some stuff. Okay, there we go. Now what I want to do is I want to actually draw the time map so we can see. Oh, sorry, you didn't actually see this here. There we go. So there's our little simulation here. Now you don't actually. We don't see the time map, so I'm gonna just add a little visualization there. All right, so where's the draw? Here's the draw. All right, so let's do self draw time map. And yeah, that's it. Draw the time map. All right, so actually we don't even need self, I don't think. Well, we do have the screen to see how big is the screen. So yeah, I mean, essentially we just need to go through time map grid size x, that is now x, or I'm gonna say I here, and then we have j. All right. Actually, I was thinking like, well, what if we had just add another another iterator here for, you know, time map. What if we just move it here? The problem here is that we don't actually get a nested loop in this case. Or, I mean, yeah, that's the point. But we don't get a multiplication of the things. We get a kind of, we just go through each list at the same time. We don't go through the first element of this while going through all of these, and then the second element of this, then go through all of these, then goes the third element, go all of this. We get like, so that's like, it would be cool if they added some way of doing that. I don't know, in a good way. But I mean, yeah, well, you could just use a nested like this. Okay, so we have our tile map. Now I want to be able to say, okay, so what would be the rectangle that we need to draw? You know, we need to draw a rectangle to be able to do this. So we have the V thing. You could do a rectangle like this, and we have like position and size, and then the color I'm just gonna use white here, or maybe gray, whatever, light gray. So we need a position and a size. Size is easy. Size is just gonna be the cell size, and that is that. Now the only thing left is the position. Position is going to be so essentially it's going to be like ij we need to provide the U size there. Whoops, what the hell is happening? There we go. So ij, whoops, like this. There we go. And then, so this will create a vector, a floating point vector from a U, from these U size stuff. Then we want to, so essentially we're mapping now from like a, from top left is 0, 0 of the screen, like top left of the screen is 0, 0 of the world or whatever, to being thinking that 0, 0 is actually going to be the center of the screen. So we need to actually add, I'm just thinking if this is correct. We need to add the screen size, half. So we need to add a half of the screen size to get our actual position. It needs to be translated and converted into a floating point number, which we are doing here. Then the question now is that, does this work with origin? I don't think so. So we are actually ending up, so this position is like the top left position of the actual, because 0, 0 is going to be, wait, no, 0, 0 is going to be in the middle. No, we need to convert from the middle to the top left, right? So this is negative. There we go. We're doing the other way around. We're translating from the center. No, wait. Hang on. Wait, it depends on this function. I think so. I think this function is saying, wait, is top left? No, top left has to be the screen coordinates. Yeah. But yeah, so if we're at 0, 0, no, then we don't actually need to translate at all. Hang on. Okay, I don't think we need to translate using the size half of the screen. let's just see what happens now. Let's just see what this actually is drawing here, and we'll figure it out. Okay, so we get this one tile in the middle. Interesting. Because this is set to be 8 by 8. Oh, right. Right. Okay, yeah. So we need to multiply this by the cell size as well. There we go. Because otherwise it's just moving by 1 pixel. It's like we're drawing 32 by 32 by 1 pixel. Okay, there we go. Now we are drawing every tile here, so we have to filter out those tiles that are not solid. So we'll say like if data, and this is going to be I plus j times the grid size 0. If this is false, we'll continue. Because this data is like it's an array of it's a flat array of so essentially a flat array is just a single. It's not a 2D array. It's a 1D array. It's just a list of booleans, so either it's true or false. If it's true, that means that we should draw it. If it's false, that means it's not solid, so we shouldn't draw it. And in order to convert to like a nested loop like this, like two kind of coordinates, lattice coordinates, into a flat array, is to be able to do this. So you have I, which is x, that is just one term, and then the other term here is the y times the width of the grid. So that's how you calculate the index in a flat array from that. So we're storing a 2D map in a 1D array. And there we go. There's our little map here. Now, the question is how we map this correctly. Because I think what's going to happen is that the center point of the tile map is supposed to be over at the center point here. So we have to basically calculate what is the size of the entire tile map, take half of that, and subtract every point here by that, so that we end up over here. So we need to calculate size half, and that is essentially going to be the grid size The problem with this is like I have to convert this to a float, and in order to do that I have to coerce it. Let's just do grid half. Also, I did a wrong convention here. It's very, very important. Not really. There we go. So grid half is going to be tile map, grid size. Actually, no, grid. I'm going to say f grid size. And that's a vector. And now that we have we have this resulting type known, we can now say float from int, which works on vectors as well. So that will turn this integer vector into a floating point vector. Because this vector is an integer vector, it's a usize, like unsigned 32 or 64-bit integer into a f32 floating point 32-bit number. So if you have a known resulting type, then using these conversion functions, built-in functions, is a lot easier to do, because otherwise you had to, if you don't have this, you have to say like as you know, as vector basically. And I mean, it's not that much big of a deal, but I think it's just easier to do it like this. So now we have the floating point version of the grid size, and then we say, okay, size half is going to be grid size times the cell size, depending on how you wanna do this, and then over 2. But yeah, the position here is, because you can technically, you know, have these ones as well to get, or modify there, or now we're modifying after we've got the position, or that's the idea anyway. The position is now translated by taking, I think, yeah, negative, because it needs to move in that direction, size half. There we go. Now we should have this correct spot, or we'll see if we have the correct spot. What is the issue now? Oh, I think we need, maybe we need to, oh yeah, wait. You can't just do 2 there. We have to actually make a vector here, which is too bad, because this is kind of, there we go, we got this. This, so now it's rendered correctly, but this is like in other languages like C++ or C#, I believe, also has overloading of operators. This is like Zig doesn't have overloading of operators, actually doesn't have overloading at all. However, this is kind of like an overloaded operator, because it depends on which context you're using it. Like now we're using it in a vector context, so it works with vector times vector, it works with integer times integer, or as long as it's the same type, it works. But if you're just adding, if you just have 2 here, then all of a sudden it doesn't work, because it needs to be a vector. So then I have this convenience function to make it into my sort of usual vector type. But it's also kind of silly, because it ends up, this overloading is happening like it's implemented in the compiler instead of like in user land, let's say. So it's kind of like an overloaded function, this here thing here. Anyway, okay, never mind that. That's just what we have to live with here. So I think it's like, but then it's also like, I think the reason why they don't have overloads is because it like kind of complicates user land, I guess. You know, having too much freedom sometimes will make it worse, is the idea, I guess. Anyway, so let's see. At least that's my understanding. There might be like some really good discussions on this, the reasons for that I haven't looked into, but that's what I can tell from that anyway. So now, all right, so we have this tile map being drawn here now. So next step is to have our little square here actually collide with this tile map using our grid hash thing. So I guess one thing that we could do is like enlarge it a little bit. We can say that the cell size is larger, so I'm gonna maybe times 4, I guess. Yeah, times 4 here. Let's see how that looks. There we go. Okay, that's just a perfect fit there. So there we go. Now we can try to see if this works here. So the goal is to make our little rectangle moving around there not actually be able to move through. So I believe we have our update function in our little thing here. So we do have the physics system. Now that's right. So actually, yeah, so we need to do a couple of things. So I don't think we actually hooked up in the physics system the collision resolves thing for the time maps. What we also need to do is actually populate the grid hash, which we have not done yet. So let's go to our main here, and somewhere we're creating our little scene over here. So I want to now create no, hang on. We could probably do it here, maybe. So we have our little, well, we have the bind function, which is like it's relying on that we have an actual pointer to the scene. The init function creates the scene data here. Now we could probably populate here, but I think it's better if we do it here, because then we have an actual pointer to the scene. So so I guess we'll do like physics system, and then we're gonna have to access the collision container directly, and then set the grid hash, and then the context doesn't actually matter. I don't know. Let's just have the debug scene there. Grid size we already have, so we can just provide that. Cell size we also have. Offset we don't really have. So the offset is the translation we need to do in order to turn a player position into a tile grid position, or well, so that they have like the same origin. So essentially, if the player is at 0, 0, this needs to be moved up to the 0, 0 where the tile map is, which is just minus half the size of the tile map. So actually, let's do this. Let's move this calculation up to the tile map, and we'll just have this size half thing that we return. And instead of that, we're doing this. There we go. And then we'll go back over here. Size half is going to be tile map size half. There we go. And then we go back. Wait. Over here. And we'll have the tile map size half. And the offset, I believe, is added, so I think this needs to be negative. So we negate it. Actually, there's a built-in for that. We just do that. There we go. Okay. then we can just rename this to offset here. All right, now we need this is tile solid function, which we can basically just define like this, and then we get the coordinate, which I believe is a grid hash grid coordinates. And we return a bool. So let's return a false for now. Now we need this thing here. Whoops. Wait, so you don't have... Where's the thing? No, it's collision, I believe. Collision. There we go. All right, there we go. Now, so what we do is we simply take the coordinates. We return tile map data coordinate 0 plus coordinate 1 times grid size 0. All right, and if that is out of bounds, then it's going to be a runtime crash, so that's fine. Unused function parameter. Right, that is not used, so there we go. Okay, so now we have this is tile solid. This is going to be called, it's like the grid hash. We give the description of the structure of the hash, which is how many cells do we have in each dimension, how big is each cell, what is the offset, and this function which describes the contents of the cell, if it's solid or not solid. Now, you know, this is like a very, very simple system. It's like you can only basically have tiles that are either, you know, empty or they're full on, like a square that is full. Well, technically you can have rectangles because the cell size could be not have to be a square shape. It could be a rectangle shape. But anyway, now we simply just we have this function that is just okay. Is it solid or not? But if you want to have a more advanced tile system where the tiles can be like slopes or things like that, then you have to kind of expand on this system here to make it work better. But this is just my like initial implementation here. So and my game doesn't really have slopes or anything like that. So I don't need more advanced system for this. But essentially, this is gonna call this function here. This is gonna just go through the grids, the cells, populate it, just call the function, populate the data there. So, I mean, essentially, you could also have a function, you could make it more generic to like, okay, let's say the function doesn't really return a bool, it returns like the actual data that we should populate this tile with or something like that, or you provide that from something else or something like that. I just made this to make it like very, very simple and to match what the thing that I'm using. So let's see. So now we have this set up here and we got some errors. All right, this is this is like an array list, so we have to use items. Yeah, because we're essentially using it as a kind of a expandable like buffer here, and so here we're making sure that we have the buffer needed and reusable buffer as well, and so then we actually populate it down here. So there we go. Anything else? You need to enable grid hash to use this feature. Yo, Ian, why a pointer to the function? I don't think you actually need to say it's a pointer. It's just that I'm gotten used to that because of how like functions are usually passed. Now, you can actually remove this, I think, and have it work anyway, because it's essentially the same thing. Like the function, you can't actually, I mean, it's going to be a pointer to the function anyway. It's going to be a constant pointer. It can't be a mutable. You don't have mutable functions in the language. So the only place that you actually need to say that it's a pointer to a constant function is if you're gonna use something like a vtable, where you can actually change out the function pointer to another function. However, in this instance, we're simply passing it in and calling it directly, and then you don't actually have to have this here. But yeah, I'll just have it because that's how the standard library usually passes functions, so that's why I'm just keeping to that. But I don't think it's necessary. I mean, otherwise the compiler will complain, and it doesn't really matter. It's basically the same thing. It doesn't matter actually, as far as I understand. Yeah. Okay, so you need to enable grid hash to use this feature. So there we go. Now we got this error here. So that is proving that the thing works. Actually, are you a comp time results? I don't know. It feels like it should know that this is a comp time thing. It's called at runtime. So let's. But what if we do that? Then that is fine. So we have to mark it as comp time, so that we have to use this in a comp time context. There we go. Okay, now the thing disappeared, because otherwise, if you don't mark it as comp time, it's like this is actually it's kind of like it's since this is the compile error is happening in comp time, this is going to get evaluated since it thinks that this is a runtime value for some reason. I don't know why, but it thinks that it's a runtime value. So it will evaluate both the true and the false of this, which will always lead to a compile error. But if we mark it as a comp time, then it will only happen in comp time, and then we actually know what this value is because it is defined in comp time. So then we only go in here if this is true, and then we get the error. So now we don't get the error anymore. Okay, cool. However, if we go to our config, whoops, if we go over to our config, wherever it is, I think it's over here, and we disable this, now we're gonna get the error, you need to enable grid hash. So we set it to true. So that is actually, I think it's a really cool feature of Zig that you can do that. But yeah, I mean, you could also like, I mean, maybe you can also like automatically enable it if you start to use it. I think there are mutable comp time variables, although I haven't really done a whole lot with those. I'm not actually sure about that. I think it's safer to do something like this instead. Okay, now we're out of errors. We have our grid hash is set up, and that should be everything you need to do from this side of the system. Now I think that the physics system still needs to be hooked up to actually use the grid hash if it's there. So I'm just gonna launch this to see if everything still works here. Okay, we got some error here. Some kind of error. Oh, we got index out of bounds. Collision grid index 0. Oh, because we're using grid size over here before we actually set it. So let's set these first. Okay. Might be a good thing. Show! Hey Blue, what's up? Okay, there we go, there you go. Now it's showing here. Okay, cool. So it still works. Now I don't think the collision works yet. So there we go. We need to actually hook this up now in our physics system to actually start using the grid hash if we are using it. So we have our collision container. Now the thing is, we have these like intersecting body, intersecting AVB. Intersecting circle, intersecting line. So all of these now are all using only the tree. They're only using the tree right now. And that does not include the tile maps. So yeah, so we need to, especially I think this one, we need to add the results of both things now. QR code game. What are you talking about? I'm just gonna BRB 1 second here. All right. How is Zig 0.16 feels? Feels like too much. I don't know. Like the thing I'm doing now doesn't really rely too much on 0.16. I haven't like enabled the incremental compilation yet. I feel like I want it to be, you know, without any compilator issues like errors or miscompilations, because I don't want to spend a bunch of time bug hunting things that are like caused because of that. When did you when you did BSP, why didn't you pre-save the binary tree? Well, I mean, it was built every time I opened the game, so it's like, or the kind of the demo. So it's like it wasn't built in a file. It was built, but it was built like one time every time you started up. I just didn't. I mean, I could have easily added some kind of cache in a file to do that, but I was like constantly, you know, I guess trying to. It wasn't the priority. Basically, I just wanted to make it work, and I was constantly like changing it, and you know. So I mean, sure, it would have saved some time, maybe, you know, by the end, but it really didn't take that long to just build it from scratch every time. It took like maybe, I don't know, 10 seconds or something. But yeah, the point wasn't to build that. The point was to actually just build it to make it work. And I did not actually succeed in that. It worked in these niche scenarios. Like it worked in some scenarios, but then as soon as you had a bit more complicated maps, it stopped working. So, you know, even if I had the caching, I was trying a bunch of different scenarios. I was like changing the BSP, doing stuff, so it wouldn't have saved that much time. But I could have built a cache. It could have saved a little bit of time. Okay, so I think all of these functions I need to like add intersecting line. I need to add the same functions to the grid hash. So we're not actually entirely done here. I'm just trying to think about what how we could do a proper like intersecting line for the things. Also, what if you have a line that perfectly goes through a corner? Will it hit the things? I mean, I guess it depends if you're considering it having some kind of width or not. Perhaps. Because I think what we're using this function for is among other things, is for example, the AI of the things that walk on the ground, if they reach a corner, or like if they reach like the end of a block and then there's like air below, then they want to turn around so they don't fall down. I think we're using this one to see that, if there's anything there, like anything solid there. Hello Bruno, what's up? Any particular reason to haven't chosen Zig? Well, there's a couple of reasons. So I was looking for a low-level programming language to do some game development, and Zig caught my eye because it had some new like ideas, or like, yeah, it seemed to have basically everything that you could do in C, or yeah, but with a more modern like tooling, and you know, the macros or whatever, the stuff like that is way more comfortable, I would say, in Zig. So that is the reason, really. I was just looking for like a low-level programming language, and Zig looked interesting, and I started using it, and then I got hooked. I think I was choosing maybe between this and perhaps like Odin, or like, I don't know, C++ maybe. But yeah, I've been using, like, when I started out, I was self-taught in C++, but and then I thought it was really cool, but but now I try to go back to it at some point, and like, I don't know, 20 years later, and it's like yeah, it just feels like, I don't know, it feels like I can't really think in that way anymore. I'm curious about its integration to C++. Apparently it's good. Well, the integration to C is very good. I don't know about C++. Actually, let me check one thing here. I think Raylib, because Raylib, is it written in C or C++? It's written in C, right? Yeah. I just think that I've seen things in C++ that is used in Zig. Like, you can, I think, in some way integrate, but the C integration is like, it's almost like seamless. Because you can basically import a C library in Zig, and then you get like auto completion, you get automatic conversion of or you get like the Zig version of the types of like you know, the integers, like the primitives, and arrays, and pointers, and all that. And you can actually define C ABI functions in Zig and have them be callable from C as well. Bun is written in Zig, I believe. Bun is written in Zig and C++ 25%. Why? Interesting. Source VM semaphore. Okay, so apparently Bun has like C++ in it. I didn't actually know that. Is it because it's using some kind of library or something? No. Yeah, no, you don't need to. You can actually create bindings. I think there are automatic tools as well as, I think there's built-in tools as well to actually create bindings, I believe. There's a thing called the translate C, which I'm not too familiar with, but I think that's what you're supposed to use now. Like, you're supposed to use this translate C built-in option, like thing when you build, when you do the define the build config, and you essentially create a Zig module from a C project, and you can just import it like a normal Zig project, basically. So essentially, you're just taking a C project, translate using a special function in the build system to translate it to a Zig module, and then you can import it as a usual Zig project. So yeah, it's actually really nice. You can essentially take any C project and import it. And actually, that reminds me, I think I have to update. I have like an instruction video on how to import Raylib, but now they have updated that, so you can't do that way anymore. Or maybe it's getting deprecated. Maybe it still works, but it's getting deprecated. But anyway, yeah. So I'm guessing you are using C++. You should try Zig. It's really cool. Now, Zig doesn't have classes, but it does have generic types, and I mean, it kind of has, you know, it has structs. You can define member functions on structs, and even unions and tagged unions, enums. But really, it's all just functions that you provide. You know, it looks like this. You have self. So essentially, it's just a function. This is a member function, although it's actually just a function that you just pass the reference to the instance here. So yeah, it's simpler. And there's no constructors or destructors, but there are mechanisms by which you can kind of have the same pattern. So using something called defer, which is really nice. If you're, yeah. Let's see. So okay. So we need to have some way of some algorithm here for intersecting with a line, actually. But let's start with just. I want to go the physics system. We have collision something. Collision container. Update collisions. Okay. Right. So we have this thing. And this essentially just populates a bunch of collision events. So we can just call, where did you go? We can call another function here. We could say like, okay, well, if is grid hash enabled, that we're gonna call well, let's just have another function. Update collisions with grid hash. And I guess this would be the same thing, like we have collisions, collision container, check collision grid hash, and we just, for collisions, we do the same thing. Right, and now it's not a tree, it's instead we're gonna do check availability, and otherwise we're gonna do like grid hash get intersections Oh, right. Right, because okay, so the trees kind of work like the trees, the algorithm for the trees is like we're not checking one by one. We're essentially inserting a bunch of bodies in the tree, and then we're checking, okay, which ones of them are colliding with each other. For this one, we essentially just want to loop through all the dynamic bodies to check if they collide with any of the tiles. So actually, yeah, we can go through the filtered bodies. Maybe it's easier if this was an iterator instead. Or we just say collisions is an array list of collisions, and we return to our slice. This is the entity. Body is gonna be self-get, or actually you get it. There we go. So we get this. We own the thing, right? Yeah. So we have to free intersections. Okay. Now, So we have our intersections, and we need to turn them into collisions. Now we have a thing for that. Actually, you know what? This is actually, we have this collision static that we need to use instead. Which has less information, I think. Wait. Hang on. Okay, okay, now it's coming back to me. We did this resolve collision static, which gives us a lot of, like, fills out all the information we need. No, actually, no. Given a collision static, it actually resolves the collision, right? It like modifies the position and velocity of the body. But we need to actually create those things. Hello, Borrow Checker. What's up? What's up? What's up? How's it going with the language? Let's see if I'm a Musy. What's it called? Musy. Oh, sorry. Yeah. It goes as it goes. Right now I gotta focus on Osu Droid monogame port. Whoa. Okay, cool. What is that? What kind of game is that? Or is it, I mean, yeah, monogame. Monogame port. Does that mean it's like a C# game? Or like the XNA or whatever? Collision static. Undeclared. Yeah. So let's just add this. It's an unofficial port for also for Android devices, made somewhere in 2015 in Java, then half in Kotlin later. Spiritual continuation of XNA. Okay, so is it your game or what kind of game is it? Oh, it's an unofficial port to Android. Oh, okay. I see. So how are you gonna make it? Not mine. It's a rhythm-based game from. Oh. So are you gonna build it in monogame then? Cool. All right. Monogame C#. One language and framework. Right. Yeah. Cool. Is it kind of like Step Mania or something like that? No. Okay. Because I remember playing that a lot, like with the keyboard. Or wait, was it Step Mania or like, I don't remember. Can I send video? Yeah, sure. Oh, okay. Oh, the numbers are the order, I see. And there's something going on the left side. Why is it? Oh. Wow. Cool. Okay, so and that's, you can download that on Android right now, or is it free? Let's see. Right, these are collision statics. Right, so they are different. Man. Maybe we don't need all this crap in here. I mean, we could turn it into a union, actually. No. We'll call this dynamic. And then collision will be union. There we go. It's free. Okay, cool. And because I can notarize Apple apps, thanks to Apple Dev Paid and also Google Dev Paid, I can do both, no problem. So no such a side loading file. Right, yeah, you can make an actual app. By community, for community. So let us quote. But that also makes it, I mean, yeah, it also makes it, I guess it makes it also a little bit more rigid, like when you want to release a new version or something like that. Let us quote Robots 2005 movie. See a need, feel a need. Needed iOS making for iOS. Okay, yeah. I mean, yeah, couldn't you also, I guess you could also make it like a web-based thing. Maybe it's hard. I don't know. Technically, yes, but mobile game for web, is that is rhythm, not really necessary. Now I was thinking more that it could be like if you have a web-based version, it could be ran on anything. Like that would be the bonus you would get there. It runs faster natively on devices. Yeah. That's true. That is true. All right, so let's see. Right. Now we have to say dynamic here instead. It wasn't as much as I thought it was gonna be. But you know the power of this. If Monogame by any chance supports, it could do Android x86. That means people may be 2-in-1s using x86 for its CPUs running an Android x86 connection. How many is that though? I would guess it's not that many. Okay. Right. Now, resolve collisions. Right. So actually now here we'll do a switch. Oh man, this is an issue. Like the collision groups are actually not part of this system. Well, let's just go with it. So let's see, because you can maybe have tiles that are solid for whatever. Let's just do this. So, so we want to switch on the collision here. If it's dynamic, we want to do the thing. We want to do this we had before. And we have all this crap over here. If it's static, we want to resolve a static collision. Right, this is actually a dynamic. Wait, but that is actually, yeah, there we go. But where is the resolve? There we go, static. No, like Linux kernel isn't. It's there in case one x86 kernel shows up. Yeah. I mean, yeah, that's great. It doesn't hurt. because all the phones are running with, is it RISC architecture? Basically. Alright, and here we have the static resolution. So, well, essentially we should just have like, actually this should be called like dynamic. And then we'll have resolve collision. We don't really need this to, I don't know if we need this to be mutable, I don't know. And then it's just like switch on collision, if it's dynamic, resolve dynamic. If it's static, we'll resolve static, and that's it. Wait, where were we? Right. All right. Right. So we have a special case for dynamic. Is collision enabled for? I guess we could make it a little bit easier. Like, is collision enabled for, and then we have the collision event that we can say. If it's not enabled, we continue. If it is enabled, we will resolve the collision like that. What is toOwnSlice for? So toOwnSlice is a function on the on array lists, which are just a dynamic array that you can, you know, expand and resize. And toOwnSlice is a function on that struct to essentially take whatever is in the array right now and the caller of toOwnSlice will take ownership of that slice. And so essentially all it, I think like all it does is really just it makes sure that whatever buffer we currently have in the array slice, in the array list, is like cleared out. Because you could have initialized it. It's a little bit of weedy there, because you could have initialized it with a read-only buffer, for example, or like a buffer that is from elsewhere and not allocated on the heap. So it's like first it checks that, okay, well, is this like allocated on the heap? In that case, we just return the pointer as it is. But if it's not allocated on the heap, then we essentially just throw it away. We also have to make a thing on the heap that copies all the data that was in the buffer. So essentially, it clears the array list, and it returns the list that was in the array list and now you have ownership of it. So you have to free it later when you're done with it, basically. So essentially, you're also another word, technical word for it is moving. So you're moving the contents of the array list. Period. That's what you're doing. I'm not sure if that was coherent right now that I said there, but essentially you're moving it, yeah, so that the struct that holds the array list can be reused for something else, and then you get the actual contents out as well. You want to see Muse's work in progress standard lib, its own test pass. Yeah, sure. So I give it a good enough until I use proper. Yeah. STL needs a lot of work and naming adjustments. All right. Cool. Thanks. I'll check it out here in a sec. I just need to get this out of my head here. Let's see. Is collision enabled event? Let's see. So I think essentially we want to switch on collision if it's dynamic. We want to return so this would be dynamic body AQ, dynamic body DQ. Okay, and then static is essentially I'm just gonna say it's true right now, but this would be how do we configure this? So essentially everything is gonna collide with the ground right now, which is not actually correct. So testing frames were JS-like, but I might look into bound test for their style testing. Do you mean like describe and it and stuff like that? It takes from Vitest at the moment. Okay. I'm not that big of a tester, to be honest. Like, I actually delved into like property testing for a bit, but then realized that property testing actually requires a lot of computer resources. But it's a real cool way of testing. But yeah, I don't know. Testing is just not that. I mean, it does help, but it's not. It's just a necessary evil. But yeah, I guess, you know, if you want to have I mean, it's very important, of course, if you have a project that's going to be used by other people and you want to make sure that things stay working. But for runic, I just like, well, let's just add a bunch of tests. AI, figure out the testing here. All right. So basically, hey, let's take Node.js language, slap ML family on this report Pascal and F# for the rest of the family, and couple them together. What? We're talking about the language. I've never done Pascal, so. And F# I don't understand. Like, I've tried to use F# at one point, but it just felt like a weird mishmash of imperative and functional together at the same time in some weird way. And I never wrapped my head around it. That's kind of what Muse is. Okay. Let's not forget Lean, Rock, Q, and Coca Unison. Okay, I've heard of Rock, but the other ones I have no idea. Algebraic effects, dependent types, type classes with laws. Do you have what the hell is it called? Yeah, is that Rock? Like type classes with laws, like you know, the language that they use to like prove mathematical things. You should build an ecosystem of Zake with same labs. Which one? Proof a system, actions, proofs. Yeah, proof. Yeah, like COQ. Because it's like, it has like the super advanced, like yeah, it has super advanced like type system, but I don't really know too much about it. But all right, yeah, I know there's others that have the same. Iris, I think, also has that. Because I was thinking about that when you said like type classes with laws. Like, do you mean type classes? Do you need type classes like in Haskell? Also, it has quote splice syntax. Oh, some partial-ish meta-programming capabilities. I mean, that all sounds really cool. I would love to look through some of the examples and see what it can do at some point. Laws give them behavioral properties. Okay. Like, are all these like features, are they like properly documented, and like, do you have examples for all of them and what you can do with it? Because that would be really cool. If you have a car, it has wheels. Laws tell this car type class expects to have 4 wheels at least. Okay, so it's like telling. Okay, so it like quantifies some of the things, like what kind of it makes up rules about what the contents could be or should be, right? Because I've always like, you know, if you have a function that is like, okay, well, it's gonna, you accept some kind of integer, but it has to be positive. I mean, sure, it's like unsigned, but you know, min and max, like minimum, maximum. The law says this car vehicle. So how do you? So are you using the type system to statically analyze that is then correct? Semantic. Okay. Cool. Awesome. Yeah, I really wanna check that out. That's really cool. Okay. Right, so this one is like event now. There we go. Right, I'm not sure why we need this to be a pointer, to be honest. Yeah, because we're modifying it. Okay, sure. Fine. Okay, so now these things, now you're saying dynamic, I'm saying not dynamic. Nope. Well, actually, these are dynamic. To be honest, they are dynamic. However, we can actually just say that they are normal collisions as well. Also, do you have a built-in LSP? Have you looked into any of that? Is there an LSP? Because if you have a functioning like type, like if you have like type errors, like all of that, it should be kind of simple. Just write like an LSP wrapper around that stuff. Like that is essentially how my LSP works. It's essentially just hooking into the type checker. I mean, I think some of the things are also, for example, the parser needs to be, it needs to like not abort the whole parsing execution just because you found one inconsistency somewhere. It needs to continue parsing the whole thing and then also pass it through to the type checker, even though you have some errors. Package manager, wow. LSP attempts to harness from the CST. Only a few rare cases may use token stream formatting or so. Split in two. Alright. I'm not sure if I follow 100%, but yeah. Okay, cool. So you do have an LSP. Think. Oh, music is like music compiler, right? Okay. Compiler's binary, music is the cargo. Right. That's a nice play on words. Play on letters. Okay, so you also need that. go. Okay. Okay. If you use JS like runtime style, the CLI will feel similar. Okay, cool. So I'm basically stealing ideas. I mean, yeah, that's what you do. That's what we do. That's what everyone does. Everything is built on something else. With some modifications. Music.json is based on Deno JSON schema. I haven't actually seen I haven't actually used Deno, so interesting. So okay. Deno, I feel like Deno never really took off. I mean, at least I haven't actually seen anywhere that I've worked at that uses Deno. Even though I really like the idea of like, I mean, I don't know, it kind of feels strange at the same time, but being able to import using URIs feels kind of cool, but also kind of scary at the same time. And maybe also even, I don't know, prone to errors or something. Deno is trying to be Node.js successor that goes to Bun. Bun is trying to replace Node. Well, I think the author of Node made Deno and tried to fix some of the issues with Node in Deno. But I guess, I mean, yeah, I guess it's just another way to make your projects. I mean, I think Bun did it in a really smart way, because you can essentially just replace Node with Bun kind of seamlessly almost. Even though Bun does have some built-in stuff for like the web server and stuff like that, so it's not fully compatible if you want to go from Bun back to Node. But going from Node to Bun should be very painless. Deno is essentially a spiritual successor, but not exact successor because of Bun. Deno is okay. Yeah, I don't know, man. I've not used Deno, so I don't really. I'm not exactly 100% sure how it works, to be honest. I've only seen I saw like snippets and stuff when it was new, but then I never really looked at it. Expected number found. Wait. So you're an ISS. Are you really saying you can't infer the type because it's not the first argument? It's a tuple. It's a valid vector type. Okay, what if we do this? Come on. No? So this is an eye size. What the hell, man? What the hell? Do I really have to do this? Oh, sorry. I don't know what I did. Did that sound like Peter Griffin? What is this? Expected F32 found U63? Excuse me? Is it like coercing the eye? Alright, it's coercing the eye size into a U63 because this is because in Zig apparently you cannot actually have signed integers in a loop, which is, I mean, it's fine because it's not really necessary most of the time, but you cannot actually have signed integers. So I think it's trying to like coerce. All right, no, yeah. These we can't use. We have to do this. Wait, no, this. There we go. Wait, did you clip it? What the hell? Okay, I can't actually hear because my headphones was... What the hell? What the hell? Okay, I was trying to imagine Peter Griffin there. Yeah, it kind of sounds like we got a sound clip. Yeah, starting to build the library here. Okay, so expected type user. Thank you for that. Expected type user is found I64. That is true. That is true. So actually, yeah, that's true. Like these are actually. But this essentially also this is a I size, so we can turn it into a U size because we're maxing out for 0, 0 here. So this is essentially, we can just say int cast. Whoop. Okay, there we go. Then you also want to be the thing. Oops. Oh, but here it's like, okay, well, technically grid size, well, grid size is a positive, so that is, this is like, wait, yeah, this is actually a U size. But this one is not. This is an I size. Wait, so actually this min here, it's like coercing this U size into an I size. U size, not our size. IU size, yeah. It's also kind of weird because U implies it stands for unsigned, but why is it then like I size and not like S size, because S is signed, U is unsigned. I guess it's because S size looks weird with 2S. I don't know. Expected type users found I64. So why? So you. So okay, let's make you into a U size. And bottom right. So actually, I would like to make this. Because technically, this could be like all the way. This could be also like negative. So we have to kind of do this to that thing as well. Bottom right. And then we'll use bottom right here. And now this should be, we don't need to do that. Actually, we do need to do this though. Unsigned int is a natural. Well, I believe some definitions of a natural number does not include 0. I mean, I guess you could just force that though to be the case in this instance. U size is weird. Why not UI size? Because unsigned int. Yeah. But the size is like, there's no other type that is named size, so it's kind of implied that the size means it's an integer. But yeah. Integer is an integer. Integer is nat. Also, you could do something like this. You could use like the mathematical symbols. Like, I think you can even do that. You can do like, wait. How do you actually get the thing though? Unicode natural numbers. Why is this website so slow? Come on, I just want to copy this. Equals. Oh, it doesn't work. Too bad. Also, it's bounded as well. You know, it's not an actual natural number. It's actually bounded by 64 bits. Or 32 if you're in the Stone Age. Okay. Yeah, Z is positive and negative integers and 0. Actually, 0, yeah. And then N is positive, natural is positive, R is real. But they really are their own domains because they are bounded by precision and size. It's like the, I don't know. I thought I was gonna think of some kind of metaphor, but I failed. Error union is ignored. Okay, cool. Let's just ignore that. Type bool is not a function. That's true. Yeah, there's not a size. There's what I meant was the types that have size in their name are all integer types. That's what I was. That's what I meant. Expected 3 arguments, found 1. Right. Okay. Man, I should have some like from int, like actual from int v. Okay, and you might think that, hey, this looks kind of stupid because we're just calling this. Why not just call this from the start? Well, the difference is that here we actually know the target type that it's gonna be. So if you just call this, we don't know what type it's gonna be. Well, if you don't know if the Zig compiler can't hasn't defined at that stage, at that point, what the resulting type is going to be, then it's going to be like you're going to get an error. But here we actually know the type already, so it kind of fills in the purpose of knowing the resulting type. So so there you go. So you can actually, so that enables you to use this in like some kind of expression without having to have a bunch of result types being defined everywhere. Okay, expected. I found the yeah. So v, there we go. Right, and we have to actually say what kind of integer is it. Technically, we can define this function to not care about that. But whatever. Let's just go with the flow here. And also size, if I'm not mistaken, is like it's similar to the C or C++ type called int, which is that it depends, the size of the type depends on the architecture of the processor or the system. I wonder if they have like, if size is ever gonna be something like 8 bits or 16 bits. 16-bit systems like Microsoft what was it, Windows 3.11. We had at some point, I think we had like a 16-bit system at that point. I don't remember. Function called at runtime cannot return value at comp time. Right, okay, so I want to see where this issue, okay, we don't have any other errors, so of course once we fix this everything's gonna work, but I want to see, okay, where does this error come from? So I have to do like a build here to get more information. We have update collisions, okay, update collisions. Right. Wait, here, yeah. So Do I have to mark this as comp time every time I want to call this? It feels kind of stupid, to be honest. Now I can mark this as comp time. However, the comp time requires that everything inside is comp time. So now this is gonna not work. However, if I just simply say if this is true or if this is not true, actually, then we return. So this is gonna generate a return statement here if this is not enabled. I mean, we could just put it in here. Actually, that feels a lot better, because then we don't need to. We can do other stuff in here if we want later. This is all only gonna care about that. All right. Okay, so that's all of the things. Now, what are we missing? We are missing, I think in here, we get the intersections, but then we don't do anything with those intersections. So we need to convert these intersections into collision events. So let us go through every intersection. And we're going to append allocator. The item is going to be a static body is the body we have. That's the thing we have. That should be the same. How can you link code in doc comments? I don't actually know in Zig, actually. So depth normal is, I think, the same thing. And velocity, wait, velocity, is that even used? Well, it's set here. Okay, so we don't need to set it. Cool. So we only use normal depth of body. Okay. So there we go. Velocity is here. Okay. Contacts. We don't use contacts because contacts is basically is only used if you want to have something like rotational simulation, like you're pushing something at the edge is gonna like rotate the object. Like, we don't have that right now, so I don't really care about that. Yeah, these are all undefined over here. I'm just gonna copy this. All right, cool. So I mean, yeah, now essentially we have, I think we've tied the knot here now. So is it gonna work or are we missing something? I'm gonna launch this thing and see if we have everything running properly. Okay, we get some errors. Let's look at that. Invalid free. Okay. A lot of remaps going on. Array list, Ensure total capacity. Add 1. Append. It's called Quantry. What? Why do we get an issue here now? Huh. Strange. That is very strange, because we didn't get this before. And now it's like we're using the grid hash, which has nothing to do with with the quad tree, so that's why I'm confused. Hang on. Okay, so let's look at this. So, all right. So this is, so you're saying somewhere in here we have an invalid free, and this is kind of where this is. This where the panic stems from? Remap from like an append in there. Okay. I was thinking like if it said like this is the source of the previous allocation or something like that, but it really just it's just a giant call stack here, I think. Okay, and there's no other information. Okay. Search and report, update position intersection, check collision QT. This is called it's not update positions, it's just search and yeah. Partial. Well, okay. There is a difference. I mean, yeah, so before, so now we do call this. Yeah. So actually we use we actually use threads, right? So we don't forget that we are using threads. So this function here is called using threads. However, I think that it's actually not using threads right now. I think because we have so few bodies, it's just gonna call this directly here. So I'm gonna see this is from, this thing is from 42, no, 511. So I'm pretty sure it's over here, no? Oh, that's from within. No. Here, 427. Oops. There we go. So essentially, it's like, okay, well, if we don't need to spawn more threads than 1 or 0, we just call this directly here. So the threading thing is not actually part of this issue. Because I was thinking like maybe the allocator is doing something weird when it's in like threads and stuff, but it is supposed to be a thread safe allocator though. So I mean, yeah, these allocation errors are like, they are some of the more harder things to debug. Why is it calling raw remap like 1,000 times here? Are we stuck in a loop here? Are we like running out of memory or something? Like what is happening here? Partial bottom up orphaned. It's just this append, I think. 793. Yeah. Append, add 1, ensure capacity. What else? Precise. And then we're at remap. So this one is request to modify the size of an allocation, allowing relocation. If the allocation element type is 0 by size, remap, and then this is like calling raw remap, and this is implementation based. So, but what is happening here? Like, why is this called like 1,000,000 times? That's what I don't understand. And then it called 1,000,000 times, and then over here we're back to remap. Then we're at debug allocator, right? So we'll go to heap debug allocator remap, and here's that function. Resize small. Invalid free. Canary. Config canary. What the hell is this? I mean, the only thing I can think of is that we're using like two different allocators or something. Invalid free. Or is it that we're double freeing? Maybe we're double freeing? No, these are the intersections. This here, this is the thing. Oh, we're initializing with a buffer. Wait. But this worked before. Okay, anyway. Initialize with externally managed memory. The buffer determines the capacity and the length is set to 0. When initializes with all functions except an allocated argument causes illegal behavior. Okay, there we go. So, okay. However, okay, I see. So the issue is that we're actually we got more collisions than we bargained for, like what it was in the buffer. This buffer is supposed to be able to keep as many entries as it should, like as it could have. Like, let's say you have 10 entities, right? So each entity could potentially collide with every other entity. So essentially each entity could have 9 other intersections. Okay, so if you take 10 times 9, that's 90. Also, there's like doubles in there. But anyway, I think it's like something like, you know, you take like 10 plus, or like, 9 plus 8 plus 6 plus 7. Something like that. That's how many intersections you can actually have. Although here we're actually taking, I think, the length is like... yeah, it's just a number of entries. So let's say you have 10 entries. The length of the thing is 10. So every entry we're going through can have 10 intersections. So when we initialize with the buffer here, we are actually... Do you set the length as well? Buffer determines the capacity and length is set to 0. So for some reason, I think the length is like exceeded, or the capacity exceeded, and that's when it tries to remap, and that's when it fails. I'm not sure why that is the case. Like, we should never exceed the thing there. So I'm not sure why that is happening, but yeah, that is strange. Because essentially what I'm trying to do here is like in previous Zig there was a thing called a bounded array, which essentially you created kind of like an array list, like a dynamic array, but it was like on the stack, sort of. I'm not sure if you could initialize with a buffer also, but essentially also like you would provide a comp time known length for the essentially you're just creating an array on the stack, and then you have some functions around it. You also have like a struct with the array in it, and then also like a length of the dynamic array. So you could append to it. It would not exceed. Well, if it exceeded the actual length of the underlying array, then you got a runtime error. This doesn't actually do that. This is different. But it's essentially the same idea, that we want to have an underlying buffer that is not supposed to be exceeded, but it's going to be, we can still use like append and all that into here. But if the array list decides to, hey, we're running out of capacity, then I think that's what's happening here. Then we get some kind of then it tries to like remap the thing here, and that doesn't work, and then we get an invalid freeze. So because the buffer in here is actually just a slice of the whole, which is the one that actually allocated. So I'm not sure, but it shouldn't exceed. That's the thing. It should not exceed the capacity. So I don't know why that is happening. This is simply, going through all the orphan entries. Unless we got double entries. Shouldn't have double entries. I mean, okay, let's just increase, I guess, the capacity here. So we've got the length. The length is number of entries. So I'm gonna make up a thing here, which is like intersection buffer factor. I'm just gonna size it up by 3. There we go. And we also need to size up this thing here. I guess this one as well. Wait, hang on. Wait, this is number of entries times, this is now passed in there. That's all. Wait, oh yeah, no, this one, we don't do that, because that's a list of slices. This one we need to do it. Yeah. There we go. So that might, you know, temporarily fix the thing. Okay, I can't seem to actually do anything. Okay, I think we have some leaks. Okay, can you please stop it? I think there are some leaks here. So that is that. Let's see, 2 on slice from collision container 549. Okay, this is leaked, right? Okay, the better pattern here is to pass in an allocator that you can then use to free it, because I think that this one 2 on slice, like this allocator doesn't necessarily, I don't think it has to be the same. Let me just double check before I say anything. But I think that this doesn't really need to be the same allocator that is used to store whatever's in here. Old memory allocated slice will remap the, oh well, it actually does remap. Well, I guess if you pass in another allocator, you would want the new allocator to actually take the old memory, I guess. Yeah, that's true. It has to be done. But I was thinking, if you pass in a new allocator, you could copy the contents, or yeah, you could copy the contents potentially and just set this capacity back to 0. Actually, you need to free it as well though. I don't know. Anyway, never mind that. Okay, so now we actually free this at the end, so that's great. Let's see if this fixes anything at all. I press exit. Will we exit now without issues? Yes, sort of. We still have a leak here. Collision container, filtered bodies. Okay. Fine. What about now? Okay. So why can't I do anything now? Like if I press C, it's supposed to show the things, and Q as well. So I don't know what is happening there. I mean, it might be that it's like pushed away everything. Let's do, where is that? Intersection check count. Let's not spam that. Okay, now what I want to do is I want to, every time we collide something, every time something is reported as collision, I want to log that out. So we've got like I mean, we could go to debug. And here's our collisions, and we can go through them. And we can add a little thing there. Oops. How does Swedish sound when you speak it? Det låter så här ungefär. Hej hej. Hur är läget? I said it sounds like this somewhat. Hey hey, what's up? Your English sounds so natural that if I close my eyes you sound American. Oh man. Swedish sounds like French. I've never heard that before, to be honest. I mean, I don't usually speak Swedish to non-Swedish speakers, but I've never heard anyone say that Swedish sounds like French. Interesting. I mean, we do have a lot of French loan words that has been with us from like way back. We actually have a French descendant king right now as well. Bernadotte. Okay. Void is not indexable. So okay, it's kind of funny actually, because we have a French descendant king who's married to a German. What about the Finns? You guys have a brotherly beef still? I mean, I don't know. I think I don't have a beef with anyone. it's like when you grow up in like a smallish village or something, you get these warped ideas about neighboring people and but it's just a bunch of rumors, and it's just a bunch of bullshit basically. Yeah, so it's like, when I grew up we had a bunch of Norwegian jokes, but then you hear Norwegians speak about it, and they actually have a bunch of Swedish jokes that are basically the same jokes, except that we just replace the Swede for the Norwegian and vice versa. And the Finns is like, it's more, the Finns is more, I mean, yeah, also as a Swede, it's like, it's also a little bit complicated because this was a long time ago, but the Finns still have, Swedish on some of the signs, like a lot of signs are like in Swedish as well as Finnish. So it's still kind of like, the what you call it, the colonization, not colonization maybe, but the occupation, no, okay, whatever it was called, we took over Finland for a long time, and Swedish was made like one of the official languages or something like that, and then it's like it's still like ingrained in Finland, like, and we don't really have that in Sweden. Like I don't really, we have no other country like that has like ingrained its like influence on us like that, except for like language, but that's not really, it doesn't really have the same kind of historic meaning there. So I don't really have that same, like I can't really say how a Finn would feel about that. I think that some Finns does feel. That's at least from what I've heard is like, but I don't know. It's like some, have some kind of beef because of that. I mean, I can understand, like, if you're growing up and you're in school and you're like, well, why should I learn Swedish when we live in Finland? And that is, I don't really understand why they still have that stuff there. But they are fully, they're fully independent to decide how they want things to be. So I think they still have like, Swedish for historical reasons, but yeah. So I can't really compare, is what I'm trying to say. If we would have like some kind of brotherly beef with them, and they would have brotherly beef with us, but then it's kind of different because they have like actual consequences in their society because of what we did a long time ago. So yeah. Yeah, sorry. I'm trying to make my thoughts come out maybe too fast. I don't know. I have a little bit of problem being like coherent and maybe keeping people interested when I speak. I actually know that, but yeah. Audiobook. Wow. Now. Okay. Thank you. I mean, yeah, that's what I imagine sometimes what people actually get out of this. What's being here is like the only thing maybe is that some sounds are coming out. Because there's like, I don't know, I sometimes I get a lot of engagement, but like people actually asking questions and something. And I actually do like that. Of course, I want to be able to focus as well, but it's a live stream, so that's kind of what it's supposed to be. People like engaging. Maybe cadence and okay, wait a minute. So are you Estonian? Can't explain it. Okay, cool. Well, that's good. That's positive, I guess. Not full blood, but halfway there. Part Slavic. Okay. Cool. Right. Yeah, of course, Estonia also. I think Estonia used to be part of the Swedish Empire a long time ago as well. So I don't know if do you know if there's any rests of that over there? I mean, of course, Finland was part of Sweden for way longer, but okay. I better know my own country at surface. Own answer. All right. What the hell is going on? Void. Are you saying that this is void? Are you a void? I mean, we could just we could return the collision events. This could be deferred, and then we return collision events. That is, yeah. Wait. This is actually a static. Interesting. This is interesting, the patterns that is employed when you're like new to a language and then you evolve with the language. You're kind of employing more like other patterns. And I would never actually do this anymore. I would never have a var like this. I was kind of thinking it's like a private static mutable. So I mean, it does have a place, I guess, but it's just so rare. I would maybe, like how I would use this right now, I would probably, if I were to do this again, I would probably just put it on the struct itself. Private static mutable is the worst thing I could hear. How can one ever mutate static? I mean, static just means, like in C and C++, static just means that, okay, in C++ you have classes, right? So each class can have instances. Each instance has fields or properties or whatever you want to call them. But a class can also have static fields, and those are just once per class. So these fields are unique per, or they're like, you have one of these per instance of the struct. Well, this is shared between all the structs, is how I'm seeing it. But it's kind of bad, because what if you want to have multiple of these? Now all of a sudden you have like, what if you want to have multiple instances? Well, now you have, you know, these are not really meant to be static. I mean, this is a bad pattern. I'm just using this to have it as a private. In C, where OP does not exist. Yeah, I think I misspoke. I meant C++, not C. But I think, does C have static? Maybe C doesn't even have the static keyword. I actually don't know. Does C have static keyword? Static keyword in C, when used as top level declaration, makes the variable function visible in its own compilation unit only. Okay, so it's very different than in C. Like in C++, it essentially just means that you have a class, if you have a static field, I think it's the same in C# and Java as well. If you have a static field, it's just one per class. It's like all instances share this stat. It's like a global, but it's like on the class. It's like a namespaced global, you could say. And it could potentially be private to that class. Rust has static, but I don't understand how it works in Rust. Oh, really? What does static do in Rust? Static declares a variable with static lifetime, meaning it lives for the entire duration of the program. Right. Static variables represent specific fixed memory address. Essentially like a global. It's a global. And it doesn't have to be constant, it can be mutable, I guess. They can be immutable or mutable, right? Oops. Yeah, so this is essentially the same thing, except it's kind of like a namespace thing. Actually, since this constructs, I actually don't know about this. You might be able to have multiple of these, like one for each thing, because this is you're calling a function, but this is comp time, so we would know beforehand how many of these you want to get. But essentially we're creating a type. This type is then tied to these static variables. So you would get, I think you would get one of these for each type that you create with this function. So in Zig, it's actually a little bit different. You can actually make multiple of these. But I mean, essentially, it's just a trick. It feels like it's just a trick, basically. You're creating types through calling a function. But yeah, anyway, these are... this is not really good to have it. These are not actually supposed to be static, so, but they are. So, and you're only supposed to have one of the instances, one instance of this type anyway. So, but yeah, in some sense, it's actually safer to have them. If it's only supposed to be one of this struct, then it might be even safer to have these as a global, because then they're not tied to you don't have to copy them around with the struct actually. Okay, anyway, expected this, found that, right, so we do that, and there we go. Okay, so now we have the collisions. We are printing them out. Let's see if this works here. All right. Okay, so we have a bunch of collisions. And we can see we have a body. And that's it. Wait. No, this is wrong. Let's see. Key, we have a normal, velocity, nothing, contact is undefined. Of course. Wait, is that it? Yeah, that is it. The body, though, ends over there. Okay. And then we have a normal, depth, velocity. Okay, so the velocity might be an issue here. In my language, comp time is written as known because comp time known. Ah. Yes, I mean, yeah, it's known at the time of reading the code? Question mark. You read comp time known. Yeah, I mean, it does make sense. Compiler known. Right. The compiler knows. Man, what if you had like an AI compiler that is like, it's taking in your code, but then it's interpreting your code. So you could get different programs. I don't know. Based on what you put in. I mean, you could just let's say you say like this. Okay, you have some code, and then you could do it with like simple. You could do it with like simple examples. Let's say I open up codex here. Yeah. And then I will say give me the assembly code for this program. Exit 0. You can essentially, it's like Loomer, or what am I saying? It's like pseudocoding. You know, you have you pseudocode. See, and it gave me. Yeah, it gave me the Linux implementation here. So it's not cross-platform. Well, it is cross-platform because I could just say for Windows 64. And there you go. Then now we've done our first compiler flag. Using AI, big 2026, whatever I want into. I mean, I've been using AI a lot because I don't want to fall behind. And I've learned a lot of things. And I'm feeling like every time I don't use AI, I'm falling more behind than I should. So I think it's important if I think especially now if you want to get like a job with, I mean just to fill in the gaps, if they require you to have, or you could also have it as a flex or something like it could give you an upper hand if another person is applying at the same time which doesn't have a bunch of AI experience, then you have like an upper hand, possibly. So, yeah. I use AI because my unmedicated ADHD wants results that match my needs, and because my brain fell behind since mid-2024 and dopamine big with it, medication. Oh, yeah. Still cheaper than paying a visit for psychological question. Yeah, you just have to beware about not thinking it's like a magic bullet or something like that. But yeah, look at this. Now we have essentially created a compiler here. Although it's probably. It's probably, you know, it's not really, you don't want to use it too much. Okay, so we've got like Windows 64. It's merely a tool, yes. Just like Photoshop is digital editing, Paint programs are the digital hours. Yeah. It's a tool, but it's a very it's a powerful tool. And it's also like we don't really, I don't think there's many that kind of sees what the potential of this tool is. And it's still being explored and new things are still being investigated. People bashed Photoshop a lot back when it came out. Digital movies instead of live shows. Yeah, and people bashed the telephone when it came out because they thought that no one was gonna talk to each other anymore. People bashed the radio when it came out because they thought that everyone's just gonna stay in and listen to radio. I mean, that part is kind of true, like TV and radio and stuff. You edited this on the computer. It's not real image, it's fake art. Yeah. AI art is not art, but whatever. You could argue that, you know, what is the effort? The effort of putting in a prompt versus the effort of creating something with your own hands. Making a beautiful image with your own hands. Like I'm appreciating some people, not all people, you know, understand that, but I appreciate handmade stuff more than like if someone just prompted something with AI, especially if they didn't do any post-processing or they didn't do like anything with the image. Like if you have an artist that uses AI as a tool and then does a whole bunch of processing with that image later, or they spend a bunch of time trying different prompts to get whatever they need to look good, then I would appreciate it. But I don't appreciate people just prompting in something and grabbing the first best that they could find. That is not really, that doesn't have the same value to me. So I understand where people are coming from when they from that point of view. A person editing a digital piece of work, making digital art. Yeah. I support AI-based coding, but not really the other mediums. Less images, more code capability. I think that also that code, like the coding part, like that is actually what could enable like any process, any kind of thing that produces something. Like sure, making images is like one thing, like that is but it was a very specific tool, like that just produces images. That's all it does. But then you have like coding. The coding part is like that is the kind of gateway to everything else. Like if you have an agentic, you know, AI, it can code and understand instructions and all that. That is then a gateway to basically creating anything, basically. Well, as long as you have the other tools, I guess. But you can, I mean, I guess you can create the tools with that agent as well. Okay. Anyway. So, so we have some collisions. What I'm gonna do is I'm gonna get a T here. I'm gonna preface these with the time. Oh, I see. So we actually don't need that. Oops. Okay. So that we can kind of see how many collisions do we have in one frame and stuff like that. So, all right. So here we have 1.39, blah, 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 144. So all of these are in the same frame, presumably. Unless there's like incredible precision and okay, we have a lot of intersections here. Holy crap. Let's do this. Let's go here and we'll say collisions. $88 collisions. Seems to be consistent. 88 collisions. And how many? Credit where due. AI tools helped me push out stuff I wanted for a long time, and they work how I wanted to work. Yeah, I mean, I used Runic like Runic. I started Runic out with only AI until it broke, but then I have to like start over and do it myself. But then, when I reached a point where my kind of knowledge waned about compilers and IR and that stuff, I just asked AI, "Hey, could you solve this?" and it just it found a solution, because it was beginning, like when you have this project that is like starting to get very spaghetti and you just don't have the energy or the capacity to actually go through everything again and try to figure it out. It just takes so much energy. And instead you can just ask AI, "Hey, could you just try to find this the solution to this?" And if it can't, then it's fine. But if it can, that's great, because then you can get forward and you can get a bunch of cool features. So yeah, I think that's really good. Impressive enough to reverse engineer proprietary synth file format used by Jagex Limited, the guys behind RuneScape. Oh, make a fully working synth based on any dev images, videos, which was not a lot due to lack of actual exploration of software. Now everyone can make OS or RS sounds. Oh, cool. Yeah, I mean, yeah, it's really cool. I mean, I think it's a really nice. It's like a revolution. It's like the Industrial Revolution, except for for software, basically. Sort of, not fully yet, because Industrial Revolution had a large impact on the number of employees. It's a good use of AI tools. Yeah, absolutely. Instead of the next to-do app or let me make money SAS garbage, you make something actually useful and meaningful. Yeah, I mean, yeah, making money. I'm not opposed to that. Like, I'm not opposed to creating something that is also then, useful, that people can use, and also you get paid for it. I'm not opposed to that. Like, I do understand, like, the position of also, like, creating very useful free things. But if you want to live the life of doing that full time, why not? Like, I'm not opposed to that. Okay, so we got 88 collisions. What is the number of entities? I think we can get those. I mean, we could just do like data, rigid body length. I don't know about making money with AI tools for others in that space, but for making things people can actually use, also out of spite for closed source things. Yeah. Is there actually anything against that? Like, if people can reverse engineer stuff? JagFX is closed sourcing tied heavily to Jagex RuneScape sourcing. So this is just false clone, but not perfect clone. We don't know much about OG software besides some basic images. And only one kind of use in dev video, but use was only one. Okay. like what they use to actually make the music. So are there like comparisons against how it sounds? Not music, sound effects. Oh, sound effects. Okay. Like, is the playback the same? Sound is correct, but the software is still not working. Okay. I see. And I'm sitting here with my BFXR, which is pretty cool. It reads and saves the files proper. Cool. So you can read the file, play it, and also make some limited modifications to it. Oh wait, are there? I mean, this is gonna be probably a stupid question, but are there like RuneScape mods? Because it's like an MMO, right? Okay. So essentially we get like 88 collisions. They seem to all be static. Oh wait, you know what? I think we forgot the offs. No, we didn't forget the offset, I don't think. RuneLite clients for all sorts is closing with plugins that don't actually affect core gameplay, so in a sense they're generally UI based macro. Oh, I see. Core life indicators more than. Ah. Yeah, because it's like you have to have a server that has the mods if you're gonna use anything, and the clients need to be properly modded as well. I just thought that because it's such a, it has existed for such a long time, maybe there was something. Okay. Right. So yeah, I think that we have actually gotten quite far here with this new system. We have the kind of test bed running here. It's just that we need to figure out why this is not really properly going on. So, but that is gonna be it for this time. I'm gonna do this next time. Hopefully we'll get the grid hash to work, and that's gonna be really cool. And then we can see how fast the game will run on that system, or slow. We'll see if we actually get anything out of this. I hope so anyway. But yeah. Thank you very much for joining. Let's see if we can raid this time. I'm so bad at remembering to actually raid here. Yeah. Let's go. Are you gonna stream, Barchecker, or? Also, I forgot to check like notifications and stuff. There's no notifications. Oh, great. Should I? I don't know. I'm asking you. Because I need to go now, but let's see, where's the button? There's the button. I gotta go. Okay. All right. Well, I'm gonna. So, okay. Well, if you start the thing, I guess I could just raid. Wait, how do I search here? There we go. No. Or are you gonna start, or am I gonna raid something else? Let's see. Ready. What do you mean ready? I don't find you here. Yeah, I don't see you on the thing. You're ready for what? I don't understand. Let's see. Ready for raid. Okay. Here we go. Wait. Let's see. Cherry. Coding. Okay, there we go. Here we go. Yeah, no problem. See you later. Have a good one.
And Lit Geek didn't know about this website, so I think he was gonna give it a try. Hell yeah, we got raided. Lumor Sunil. I hope I'm pronouncing your username correctly. Thank you for the raid. I borrowed check, by the way. We found a Rust enjoyer in the wild. Hello. I also borrow check sometimes. How's everyone doing? Close enough. Lumor Sunil. Yeah. It's